Let's talk about local maximums and local minimums. A function f has a local maximum at x equals b if there exists an interval from a to c with a being less than b being less than c such that for any x in the interval, ac f of x is less than or equal to f of b. What in the world is that saying? So all that means is that if we look at a little interval, so here this would be, this graph would probably be continuing, but we're just looking at it between A and C. You can see that this graph is, if we just look at that little interval, so that little neighborhood, we can see that at that value B, it is the largest point on that graph. So a local maximum means if you just look at a small interval of the graph, you have a local maximum there. There's a largest value there at that point. Likewise, a function has a local minimum at x equals b if there exists an interval ac with a being less than b being less than c, such that for any x in the interval ac, f of x is greater than or equal to f of b. So that means that this y value is smaller than any of the other y values in that interval. And if you look up here, this means that the y value is greater than or equal to any of the other y values in that interval. So that's what makes it a local maximum. This is what makes this a local minimum. So looking at this new picture, you can see we'd have, if I drew a little arrow, like a neighborhood right here, you can see there's a local minimum there. If I look at this small interval, that we have a local minimum at this value. It is the smallest value in that neighborhood. If I draw a neighborhood right here, there's another local minimum right here. If I draw a neighborhood right here, this would be a local maximum right there. That is the largest value just in that neighborhood. Again, we're not looking for the entire function just in that neighborhood. If I draw my neighborhood here, there is no local minimum or maximum because there is no largest or smallest value where you have that's in the middle of an interval. So that's the other key thing, is for it to be a local minimum or maximum, you have to have points on either side of it that are either both are above it or both below it. Okay, so again, if I draw my little neighborhood, this would be a local minimum because just in that neighborhood, this is the smallest value. And the local minimums are those y values. So here the local minimum we'd say is -1. Here we'd say the local minimum is about 1/2. This would be a local maximum, again, because points on either side of it are smaller than it. So I'd say we have a local maximum at about 1. Now let's talk about absolute maximums and minimums. The absolute maximum of f at x equals c is f of c, where f of c is bigger than or equal to f of x for all x in the domain of f. So all that this is saying is that it is the largest y value. It's bigger than any other y values for the entire function. An absolute minimum, likewise, occurs now where it is the absolutely smallest y value for all of the x values in the domain. Another way, so probably some of you are saying, huh? So the absolute maximum is the absolutely highest value the function takes on. The absolute minimum, it should say minimum, is the absolutely lowest value the function takes on. If you want more information on minimum and maximum values, go ahead and click right here and it'll give you some more. So let's look at an example. For the function shown, find all local maximums and minimums as well as any absolute maximums and minimums. All right, let's look at the local maximums first. So it looks like I'd have one right here and another one in this neighborhood right here. We could say that, so the maximums and minimums are always the y value. So the local maximum is actually 16 in both cases. So we'd say there's a local maximum of 16. If you're ever asked to state where it occurs, then that's when you state the x value. So that occurs at x equals -2 and at x equals +2. The local minimum. All right, it looks like we have a local minimum right here where if I draw a little neighborhood on either side, the y values are above from 0. So your local minimum, there's one at 0, and that occurs at x equals 0. Now this would not be considered a local minimum because again for the definition you have to have values on either side. So there's values on the right hand side of this, but I don't have any values on the left hand side. So that's not considered a local minimum or a local maximum. For finding the absolutes though, those are the absolutely biggest values that the function takes on and the absolutely smallest value the function takes on. So here, the absolute largest value this function takes on is 16. And for the minimum, the absolute smallest value the function takes on is, I would estimate that at about -10. Again, this is not considered a local minimum because there are no values on the right-hand side of that point. So that's just an absolute minimum. We can actually use technology to find exact local minimums and maximums. Click on the corresponding technology resource to learn how to use it to find minimum and maximum values to answer the following question. The solution can be found on the next slide. Use a graphing utility to find the local maxima or local minima of f of x equals x squared plus 2x plus 1 for -2 being less than x being less than 2. Then determine where f is increasing and where f is decreasing. I personally love to use the website Desmos to do this, and you are more than welcome to use that as well. That's what I'm going to demo on the next slide. To use Desmos, first go to www.desmos.com. Or you can click on the next slide, and I actually have Desmos inserted in there already for you. Now click Start Graphing. Desmos will open up, and you'll see on the left-hand side is where you can input the values. So let's type in our function. F of x equals x squared plus 2x plus 1. And there's our graph. And it wanted us to specifically look at x values between -2 and 2. If you want to ever you can zoom in and zoom out using your mouse cursor. So I can see here that between -2 and 2, there is a local minimum right here. And what's great about Desmos is it automatically puts points on what they call important points. So or interesting features. So anytime there's a minimum or maximum, it's going to have these little gray points on it. This one it has a gray point on because of the fact that it is a y-intercept, which is another interesting feature of this graph. So we can see here that this graph has a local minimum, and actually it's an absolute minimum, but at -1, 0. So you'd say the local minimum is 0, and it occurs at x equals 1, -1. We can also say that this function is increasing as I am going away from that local minimum, so it's increasing from -1 to infinity, and we can say it's decreasing from -infinity to -1.